What do you think are the odds that there is life elsewhere in the universe?
They must be high, and I'll tell you why. People say, well, have you found life yet? No. Well, that's like going to the ocean, this has been said before, taking a cup of water, scooping up and saying, there are no whales in the ocean, Here's my data.
There is no doubt about it. We are not alone in the universe. With research showing that moons Europa and Enceladus have warm liquid oceans under their surface, as well as life being able to thrive at the bottom of our oceans using oceanic vents, no sunlight involved. It is entirely possible that sea creatures and microscopic life may have, at one point, swam elsewhere in the solar system. That means that life may have sprouted up several times in just one solar system. And because the number of moons in the observable universe far outnumbers the amount of planets, which by the way is 1 septillion, that would imply that the universe is teeming with life. But the discoveries on Europa and Enceladus don't only expand the parameters needed for life, but they also imply that most of the life in our universe is not intelligent life. So what about the fantasies of galactic civilizations that have perfected light speed and surpassed the life of their home star and spread out across the galaxy? Why haven't we been contacted by anyone like that? Well, let's start with this. In order for a planet like ours and a species like ours to come about, one cycle of stars have to die. This is because when the universe started, all of the atoms that existed were hydrogen with the occasional helium atom. The heavier elements in our body, and in the Earth, like carbon and oxygen, are formed through nuclear fusion in the cores of stars, where immense pressure and heat squeeze atom nuclei together to form other elements. But those elements are still in the star. It's not until the star dies in a supernova explosion that the elements spread out across the universe to form planets and life. Now, the average life of a star is 10 billion years, but the universe is just 13.8 billion years old, which means that we have just started the second cycle of stars, the first cycle that can maintain life. That means that all other civilizations out there are around the same age as ours, meaning that they are about equally technologically advanced as us. Even if they were older and more advanced than us, there just isn't enough time for them to be old enough to be at the point of interstellar travel. This doesn't just disprove the "a long time ago" part of the Star Wars intro, but it implies something much greater. There are two majorly accepted theories for how the universe will end: the Big Rip and the Big Freeze. The Big Rip goes as follows. Our universe is expanding at an accelerating rate because of something called dark energy. Scientists don't know exactly what it is, but they know it's there. Not only that, but they know it's the majority of the universe, 70% of it in fact. The hypothesis is that around 22 billion years, the expansion of space will be so fast that gravity will not be able to compensate, so galaxies will be torn apart, then planets and stars, until finally even atoms are torn apart. That leaves us at a little past the 1/3 mark of our universe. But another equally possible scenario is the Big Freeze. In that scenario, the universe only dies when entropy is at its maximum, and every single atom is converted to energy, until no more stars can be formed and all activity in the universe stops. A process that will take approximately a Google years. That is 1 with 100 zeros behind it. That means if the Big Freeze does happen, we live at the very beginning of our universe. In fact, that would mean that the universe is so young that the percentage of the universe that has already passed is this. That is 53 zeros after the decimal. And while the universe is just starting its second cycle of stars, this is how many cycles of stars are going to go by. And each of those are 10 billion years long. That should give you an idea of how young the universe is, and how we are alive at the very surface of what is to come. While both scenarios, the Big Rip and the Big Freeze, are not optimistic, the Big Freeze has the better outcome because it leaves more time for civilizations to advance. The Kardashev Scale is a scale that ranks how advanced a civilization is from 1 to 5. 1 being planetary civilizations, followed by stellar, galactic, universal, and 5 being a multiversal civilization. So if we want to reach rank 5, we should hope that the universe ends in a big freeze.